Hey everyone, welcome back to another video. This one is long overdue, so we're going to dive right in. If you were able to watch my last video, you'll know that I went to DEF CON last year, and as part of that experience, I got to play in a little bit of the Embedded Systems Village CTF at the very last minute. It was a lot of fun. I was able to actually pop some boxes, get my name on the scoreboard, and it was cool. But during that experience, I exploited a vulnerability that is pretty well known and is a sister to a vulnerability that I'm well known for here on this YouTube channel. So if you're familiar with my OSCP Journey series, you'll know that I'm the author of AutoBlue, which is a set of scripts and automations and improvements, and is also a port of the NSA leaked Eternal Blue exploiter MS17010. And this exploit targets the SMB service and allows for, well, remote code execution. And it's what helped the WannaCry ransomware epidemic spread pretty rapidly. Now, I obviously did not author the exploit. The NSA did, and some researcher there. I also didn't write the original Python exploit. That was written by, I think their handle is Warweight. Warweight published this code, and it kind of went out of date pretty quickly, and I took it upon myself to modernize it and maintain it from there, and I've been doing that ever since. So if you've ever used AutoBlue, or if you've ever used a modern variant that didn't require Metasploit or ZZZ exploit in any modern context, you probably used my toolkit. And that's pretty cool. I use it every day too. A lot of my other team members do. It comes in handy whenever those systems still pop up. And yes, they do still pop up in 2026. But we're actually seeing less and less of Eternal Blue, at least in my experience. It's not empty. It's still out there. But this vulnerability that we're going to talk about today is a lot more common than you might think. And it came out around the same time, or was popular around the same time, and has the same impact. You might be familiar with it by the name of Sambacry, or CVE, whatever it is. I don't memorize CVE numbers. I'll put it up here on the screen or whatever. But Sambacry, it was named that because this is a vulnerability that targets Linux Samba services. And as a result, we nicknamed it in the community, instead of Sambacry, it has another nickname that I prefer to call it, Eternal Red. So you have Eternal Blue targeting Windows and Eternal Red targeting Linux. So that's the vulnerability we're going to look at today. It's not really complicated. It's just one that I don't see a lot of people be aware of, and it matters a lot. And before we dive in, I'm going to talk about why it matters. So the reason this matters so much, and the reason this was present in the Embedded Systems Village CTF, is because Samba services in the context of industrial control systems, IoT systems, any kind of embedded system environment where they're using these Samba services, don't receive patches as regularly and are running on some weird code bases or even completely custom distros, and all kinds of combinations of configurations. Even if it's just the bare minimum, they're not getting updates like every other Active Directory environment that you go into the corporations with. Industrial control systems environments can be just as hectic, and they have to run constantly. So it's kind of hard to find patching windows if they don't have failovers. There's a lot of ifs, ands, and buts. So you end up seeing this really easy to identify and exploit vulnerability in these environments, and are able to pop these complicated environments over Samba. And it really doesn't take much. And in fact, let's dive into it, and I'll show you what that looks like now. All right, so Eternal Red. What do we need to know about Eternal Red in order to exploit it? Well, we need access to a writable share. That's the first requirement, right? So it doesn't necessarily mean you need creds. You might, if the share is locked down, you might need some credentials to access it, or at least anonymous access, and you need to know the name of the share. Once you know the name of the share, you just need to know the path that you're writing to. And, well, you're the one writing to it. You have write permission, so you know exactly where you're writing the file. And then once you do that, you can exploit Eternal Red. So we're going to look at some of the source code for the Metasploit exploit, as well as another publicly available proof of concept exploit, and take a look at kind of how it's going through the code and working. I think the public GitHub exploit will be a little bit easier to understand, but at the end of the day, both of these are pretty important, and we're going to use Metasploit just because that's how I did it in the competition, and I want to show just how easy it is. But fundamentally, this is not a very complicated exploit. So we're going to take a look at the Metasploit module first. And in Metasploit, this exploit is called isKnownPipeName. And there's a reason for that. That's because the trigger is knowing the pipe name. If you remember back to the picture we were just looking at, you need to know the path. Well, that path is going to eventually become loaded in as a pipe that you pass through in the context of the SMB or Samba service. And when that happens, all kinds of magic happens, and then we get a shell. And we'll walk through what that magic is. But Samba versions 3.5.0, 4.4.14, 4.5.10, and 4.6.4 are some of the confirmed vulnerable versions. I see this all the time. And where do you see this? Well, in the context of the Embedded Systems Village CTF, this was, I don't know if this was an intended path. I assume it is, because the people who wrote the CTF are very well aware of this vulnerability and love showing it off every so often. But at the same time, I also found some other paths of remote code execution. So there could be multiple paths or whatever. This one was just easy, so I took it. And Samba runs as root. So once you exploit it, you get a root shell. But the device this was working on in this case was a Western Digital home cloud solution, storage solution. So like a little mini NAS, consumer mini NAS. And you got to think about systems like IoT devices that get pushed out and they have their base firmware. When people plug them in and install them, they're not updated. They don't have the latest patches, if there are even patches available for those devices. So that's one instance where you may see something like this show up. I've seen this show up on TrueNAS, for example, back in the past. I'm not even sure if they've patched it. I'm pretty sure they have. They should have a patch for TrueNAS. Stays on top of things. I haven't done that in a while. That was a couple of years ago, and I looked at a buddy's environment at home recently, and all that kind of stuff. But even if you are running a vulnerable version of Samba, keep in mind that you still have to have that prerequisite of a writable share. So you have to be serving a share. It has to allow write access, and if you have a credential in front of it, that may be even another barrier to entry. But you may find this on any system that's serving Samba that's prepackaged as an embedded system because it's just running whatever version it had at the time, and it might be vulnerable. And it happens more often than you might think. So that is kind of the baseline here. When we go through and take a closer look at this Metasploit module, we're going to skip through all the Metasploit specific stuff. I just kind of want to show the baseline of what we're doing here. Okay, so here in the upload payload, we do a connection to the SMB server and upload our payload. Simple as that. And then right here, when we go to trigger payload, this is the next kind of secret sauce of the step, is that we do this client create pipe. I want everybody to pay attention to this. Simple.client.create pipe. That actually triggers the loading of a shared object library into memory, which will launch our shell ultimately. I'm going to talk about that a little bit more and why that happens, but I just want to show in the Metasploit module, those are the two steps. That's it. Upload, trigger. And the upload is just an upload to the file share. The trigger is this client create pipe. And we know the pipe name is known pipe name, right? And that is the path to our payloads. That's the Metasploit module, just in a quick nutshell. But let's take a look at the exploit.py code that's kind of publicly available. Now, I've had some trouble getting this to work consistently. I've been working on some updates. Maybe I'll push out my own version of Eternal Red 2. Who knows? We'll see. But there are a lot of variants available. There's also one on ExploitDB. Your payload type may vary, but the idea and benefit of doing this manually, just like with the AutoBlue exploit that I maintain, is that you can bring your own payload. So in the context of AutoBlue, you're bringing your own shellcode. In the context of Eternal Red, you're going to bring your own shared object library that you can load into memory. And this can be a shared object build of a custom implant that you have, or maybe a rootkit or whatever, which a rootkit would be very smart because Samba runs as root, like I mentioned before. So let's take a look at this exploit, and we'll see kind of the same thing happening as before, but we're going to see something kind of special that gives us a better idea of what's happening under the hood to actually trigger this vulnerability. Okay, just like with our Metasploit exploit, the steps are exactly the same here. The details are just a little different. So here we're using SMB client.put file inside of Python to just write our shared object library. So there we go, upload the file, step one. And then we're going to trigger it. But how is that happening? Well, in the Metasploit module, it's kind of obfuscated by that line that we looked at before. Here we see a more clear-cut command that's getting passed through to trigger our loading of our shared object, or to trigger the loading of the pipe name. So this trigger module is calling this ncacn_np and then passing in a pipe. Okay, cool. We know that we're uploading stuff and we know that we're triggering it, we get shell. What's actually happening to cause the trigger though? None of the code makes that clear. That's the actual vulnerability that's lying underneath. So I'm going to walk us through that real quick. Okay, so what's happening is basically this, that ncac_np, that call is a RPC call to open a named pipe. And when that happens in these versions of Samba, that pipe path gets passed into a DL open call. And this DL open call will see a shared object library, load it, and run it. That's just how that works, and that's why this is so simple. So that's the trigger for the GitHub exploit, but inside of Metasploit, that function call that it has to create the pipe does the same thing. The idea is you just need to call some kind of command inside of Samba that you can pass a path to for your shared object library and have it eventually trickle down to call DL open. And in the case of Metasploit, it's the function it's using calls this nt_create_and_x function. And that also just calls the DL open and makes the shared library path work. That's this vulnerability. It really is that simple and gives you straight root remote code execution. Now, remember, we have the caveats. You got to have a writable share, and you may need some creds. But most environments where I see this, you'll have some kind of guest share or anonymous access or something's left not configured. Maybe it's like a backup share for automation on a network. So for sysadmins, one of the things you can do especially if you're trying to harden like an industrial control network or something, is put credentials on stuff, man. That'll make it harder. Ultimately, you do want to patch, because if somebody can find credentials, they can still exploit this, and now it becomes a privilege escalation issue, right? But at the end of the day, this is not a very complicated exploit, nor is it difficult to actually take advantage of. So let's do that. Let's go ahead and hack something. So I've got a Docker container from Vulhub that is running Eternal Blue. If you go to Vulhub and go to the Samba folder, it's there. That is the Sambacry vulnerability running right inside the Docker container. So inside of Metasploit, this exploit is known as isKnown pipe name, and you can find it by using exploit linux samba isKnown pipe name. And just taking a quick look at the options here, it only really allows for one payload type. So Metasploit doesn't really allow us to set like a custom shared object or something like that. It pretty much only supports this command Unix interact and drops us straight into a shell, and that's all well and good for our demonstration purposes. But that's why the public exploit code is so much more useful as a modern attacker, because you can customize what payload you're going to toss at it and think about persistence and stuff like that. But if this is your initial access and you get on the target, you've got a root shell, full command interaction. You can just upload something later. It's not that critical, but just things to consider and think about from an attacker's perspective, rather than just using a Metasploit module out of the gate. Nothing wrong with Metasploit though. It's going to work great. So we're going to set our remote host. Like I said, I'm running in a Docker container that is vulnerable, and we are going to just target it. It's listening on port 445 already. This supports check, so we can actually verify if this is vulnerable or not. And with that check, it found a share for us. It says, hey, this is the writable share that we're going to target. Now, in the exploit, it also tries to enumerate and find those shares on its own. If it can't find a share, but you know there's a writable share that you've enumerated, you can pass that through as an option and see it right here in the SMB folder and SMB share name values. And it'll work that way too. From here, though, it's really just exploit. We're using Metasploit. Everything truly is that easy. But we can watch through the steps as we're going. So it's using that location of my share for the path. It's going to retrieve the remote path for us, and that's the data it's going to use when it's actually trying to write our payload. All right, we had some technical difficulties, but I literally just ran it 2 more times, and then it worked. So we got command shell session 1 open, and we're in it, and we are root. We can see everything about this host, and we're just inside of our Docker container as root. And it's really that easy to exploit, and this is how I got into one of the boxes, and I don't know how many points it was worth, but it boosted me up pretty quickly, and it was truly that simple. So the whole reason I wanted to make this video is one, because it's Eternal Red, and I'm kind of known for Eternal Blue, and I wanted to talk about this because I've never talked about it before. 2, it's simple, and 3, people don't really talk about it too much. If you're not in the space of embedded systems, if you're not in that realm or sphere, this died 10 years ago. It's been patched. Nobody's worrying about it anymore. Yeah, maybe in your AWS environment, but not in industrial control systems, not in consumer IoT devices and stuff like that. This thing is still everywhere to this day, just like Eternal Blue is. And it is just as exploitable and wormable as anything else that something like a ransomware group that launched WannaCry would want to use. And that's why it was nicknamed Sambacry. But over on this channel, we're going to call it Eternal Red. So that's it for today. I just wanted to share this quick video with you guys and walk through this exploit and explain it in detail and kind of do that. And it wasn't meant to be a long video. So hopefully you enjoyed it. Hopefully you learned something. If you haven't checked out Red Team Engineering, please do. And also keep a lookout for my next video. We got some unique promo codes for a special thing that I'm launching. So yeah, keep your eye out, and peace.